Hi, I'm Ravikant Manchana. My project is wildlife animals detection through images. I built a deep learning model that can automatically recognize wildlife animals from images. Basically, the idea is that in real life, forest rangers or researchers capture tons of images using drones and camera traps, and it's hard to go through them manually. So, I wanted to create a simple image classifier that could identify animals using deep learning. This project is important because it can help in wildlife monitoring, species protection, and even in smart camera systems, which can be used in parks. Before getting into technical part, I just wanted to quickly highlight some research questions that shape this project. First, does resizing images to a fixed size affects model performance? Second, can the model still perform well if it trained from scratch? Third, how well does the model generalize to new images with different lighting and angles? Fourth, can a confidence threshold help avoid unknown predictions on different animals which are used from Google? And finally, does saving the best model during training improve test results? These questions helped guide my design in this process. Um, Next, uh, I used Kaggle dataset, which can be seen here with which are organized into folders by class, and they are already resized, but I also resized them here, which you can see here. um, uh, this directly connects to my first research question, because consistent input size is essential for stable training. I used i used efficient net v2 because it's lightweight but powerful model that balances accuracy and speed. It's good for image classification task, which is like my project. Um, I also imported Torch, because PyTorch is the framework I use to build and train my model. It provides everything from like tensor operation to training loops, basically. I also imported timm, which is a library full of pre-built image models, like EfficientNet, YOLO, and like there are many. Okay, and in this, so this is the I've set pretend equal to false, um, because Kaggle doesn't allow internet access during training. So I set pretend equal to false and trained the model from scratch. Here I set epochs is 15. Um, Normally, one epoch means that model has been seen the entire training dataset once. That means like it went through every image. I trained the model for 15 epochs, which means it looped through all training images 15 times. I picked 15 because it's a good balance, enough for the model to learn, but also it doesn't overfit. Here is the validation loop, and I set validation is zero point 0.0, which is this variable keeps track of best validation accuracy we have seen so far. So during training, if a new epoch does better on validation data, we update this value and save that model. In this block of line, this means like we are saving the best version of the model based on validation accuracy, not just the last one. So if I set 15 epochs, it takes the best one out of 15 and not the last one. It connects to one of my research question. Instead of using the last epoch, I use the best version during training, which improves real world performance, which is what we want. And here I have these are some curves, which shows training and validation loss curve. First one is loss curve, and second one is accuracy curve. On the left side, we can see the training and validation curves, which loses over every epoch, and we can see the trend. It goes downwards, which is what we want, because it's a loss and we don't want it. And the right side, accuracy grows higher and higher through every epoch, which is what we would like to see when training the model. And here I tested 6 images from. I created a data set with 6 images, three known and three unknown. All of them are from Google, and I tested here, which are resized into 224 by 224, like I said in the beginning. Um, the first one, it predicted right tiger, and with confidence of 62%. Second line, it re- it predicted also right with low confidence because of the resolution. And third one, it predicted also right cheetah with 98% confidence. When it comes to, as I said, confidence up to 50%, which I'll show right now. I set a threshold here, confidence threshold. um, After the model makes a prediction, it also gives like confidence score. So I added a threshold of 50%. If the model isn't at least 50% confidence in what it is guessing, I won't let it guess. Instead of forcing a guess, it just says unknown. um, like this also answers one of my research question about like improving prediction safety. We don't want wrong predictions. So here the confidence was too low, less than 50, as you can see. So it predicted unknown. But when it comes to these two images, the unknown images, which are not in my data set, giraffe and bear, it predicted cheetah and fox with high confidence. It is because it this tells the model that like it saw visual patterns, it thought very similar, but this giraffe has similar pattern like cheetah, so it thought it is cheetah and predicted it. Same with this like bear, it due to similar pattern, it the model thought it was fox and predicted with high confidence. Classification report, this is for classification report. Classification report consists of like precision, recall, and F1 score. Precision is like how many of predicted lions were like actual lions. Recall basically tells us that like how many actual lions were detected by the model, and F1 score is basically balance between both of like precision and recall. Um, Here we can see the accuracy between like we got 52% for and for most of the trained model. This confusion matrix also. Okay, before going to confusion matrix, I also wanted to say in the cheetah resi this block right here is giving 0 because um, um, like like due to data resolution problem, I could have merged them into one cheetah class, which would like improve models performance and generalization, but I didn't because like it would affect the other classes. It only affects cheetah now, so I basically let it be like that. Confusion matrix is, this matrix shows that like how our model predicts each class like and where it gets confused. The diagonal means like correct predictions, and off diagonal means like it gets confused, like where it makes mistakes mostly. So this confusion matrix shows that mostly our predictions are right, and it predicted each class correctly, especially along the diagonal. Uh, but also struggles slightly with image variations causing by resizing, because in our data set, for every class it has three sizes, I mean three resolutions, so it is getting bit confused. We could have avoided it if we want, but I let it because like it improves training over time. So to improve this, I consider like merging all resolution variants into specific single label, like merging lion resize into lion glass. This would have simplified the model job, um, likely improve the accuracy too. So to sum it up, I built a wildlife image classification system using EfficientNet V2S, trained it on Kaggle from scratch, and added a safe prediction behavior using confidence threshold, like I showed here, this part. Um, this project shows like how deep learning can help in real world conservation and wildlife monitoring tasks, even with limited resources. That's it for my partner. Thank you.